This chapter introduces the different controller modes, that is, the different ways an electronic circuit can behave when controlling a physical phenomenon. The most common method is called on-off, as seen in home heating systems, where you have a set point and then the heating system is going to turn on when a certain set point has been reached. Because we only have two positions, on and off, we say the system goes from either 0 to 100%. There is no in between. A common problem with on-off systems is that if you are slightly above or below the set point, the system will turn on and off too quickly, and this might cause damage. A solution to this problem is to have an area, say negative or positive 2 degrees, where no change will take place. This is called a dead band. That is, the system will not operate until it gets above or below 2 degrees. The formal name for the dead band is the differential gap. And remember that no change will take place until you get outside the two extremes. For more precise control, we use proportional control. In this example, we're going to measure temperature using a thermistor. When using a thermistor, a Wheatstone bridge must be used, and then the measurement is sent to a differential amplifier because it's a very small signal. The signal from the differential amplifier is sent to a summing amplifier where it is summed with the set point, and then the correction of the temperature can begin. When the error is great, the system operates at a very high proportion, but as the corrective action begins, the error gets smaller and smaller. Then the system operates at a smaller proportion. So no longer are we operating on and off, but we can operate anywhere in between 0 and 100%. The whole idea of control is that there's to be an error, and we got to solve the error to reach the set point. But as we begin correcting the error, it is harder and harder to detect the actual error and harder to amplify it. And so the result is that an error always remains, and this is called the offset or steady state error. Because we are using op amps in measurement and also to drive control circuits, we can change the gain to make the system operate faster or slower. The result of using too much gain is that the system will overshoot the set point and begin to oscillate until eventually it will find the set point. Of course, the result of using not enough gain is that the system might not ever reach the set point and operate very slowly. In electronics, when we're talking about gain, we say it's V out or V in. But in control electronics, you see it's always percentage output divided by percentage input change. And then the other formula also has to do with the percentage of change.